Hello and welcome. What we have here is a solution to the very first problem of the second part of the problem set. We were required to design a GUI for the rover control station, and here it is. Here are some labels that display real-time data of the rover broadcast by some onboard networking devices, but we don't have one, so we have to be content with a simulated one. So let me fire it up. Now you can see the labels are changing their values because the rover stats publisher, our simulated control station, our simulated networking devices are broadcasting data into our base station. We can also see the graph that says the rover state publisher is publishing data into rover stats topic, which is feeding data into turtle mover. The turtle mover is actually our GUI, which is again feeding into turtle1/cmd velocity, and which is turtle mover is feeding the commands up and down, left and right into the turtle1 command velocity. In here is our rover, i.e. the turtle, and eventually it is getting fed into turtle sim. So let us try to control our rover/turtle. It can move, it can go up and right, and we can stop it at will. Then we can move it and then go down. So let us stop the thing. Let us turn off the publisher. Yes. Oh, actually I do need the control CY to explain you the code. Anyway, so we turn off every other thing. Now let's look at the code. We start by importing necessary modules, Tkinter and ROSPy, of course. Now this is a flag, and which I am going to explain later how it is used. The class turtle mover basically creates this whole window and everything within it, the labels, the buttons. We initialize the stats to 0 and declare a publisher and a subscriber. Now all of this, starting from here, this self.stop.frame down to here, self.button.greet, just before this define update labels. All of this bulk of code controls how every text and labels and buttons are styled. For example, the self.battery.label, it says that foreground has to be green, background has to be light green, and what should be the text, and the width and height of the boxes, the border width, and every other thing up until this point is about graphics. Now we have to explain how all these functions work. Let's start about what was that flag about. Running equal to false. Okay, as we saw, the turtle moves. It moves either forward or backward, and it turns. When this running flag is false, the turtle doesn't move. It doesn't move forward or backward. It can move right or left. When this running is true, it is either moving forward or backward. Okay. Define stop. How do we define stop? Just we make that label false. Now here we have the start forward and forward methods. This method, the start forward method is, and the forward method are used to control the turtle's forward movement. And as you can see, just remember this start forward method, we have fed this start forward method into the callback of the self.up button. And similarly, there is a start backward method. The that is used as a callback of the down button. Now, why use this kind of construction? Here is a start forward and here is a forward. Now, when I am pressing that button, I don't want the callback to go forever, because if that happens, I will not be able to press the other button, for example the stop button or the left or right button. So I want the callback to terminate. Here, and then um, the act of moving forward is carried out by the following function. So the callback exits, but the turtle keeps moving forward because of the self forward function. Similarly, there is a start backward and a backward function. The start backward just starts the turtle to move backward, and the backward function carries on the movement. And there is a turn left and turn right method that makes the turtle turn for a specified amount of time. For example, is 0.3, and at a specified angular speed, 15 degrees per second specifically. And that's all. That's all about how the program is designed. And thank you. Bye.